Hello, today's learning objective is to be able to add and subtract rational expressions. We already know how to simplify a single rational expression. We know how to multiply and divide rational expressions. Now we're adding and subtracting rational expressions. So first, let's remind ourselves how to add and subtract fractions. Try these out. Pause the video and we'll talk about it. All right, to add and subtract rational expressions, we need common denominators. To get common denominators, we're going to multiply by 1 because 1 doesn't change anything. Does everybody see how that and that, those two expressions are both 1? 8 over 8 and 5 over 5 are both 1, which leaves me with 24 over 40 plus 35 over 40. Now that we have common denominators, we can add and subtract. So this gives us 59 over 40. And then we take a look. Can this be simplified? No, it can't be simplified, so we're finished. With the second one, if you multiplied by 9 over 9 and 6 over 6, that will get you the right answer. It would leave you with 48 over 54 minus 45 over 54, which will be 3 over 54. And then you take a look. Can it be simplified? Yes, it can be simplified. And you wind up with 1 over 18. And this will work, but it's easier if you multiply to get the least common denominator. The least common denominator here is 18. So instead of multiplying here by 9 over 9, I'm going to multiply by 3 over 3. And over here I'm going to multiply by, by 2 over 2. And this will give me 16 eighteenths minus 15 eighteenths, which is 1/18. And now we don't have to simplify. So by going for the least common denominator, we avoid that last step of simplification. So let's apply our understanding now to expressions with variables. Try to add these, pause the video, and we'll talk about it. As was the case with the previous example, you could multiply the right fraction by 3x over 3x and the left fraction by 4x over 4x, but that won't get you the least common denominator, and you'll wind up with an expression like this, 47x over 12x squared, which needs to be simplified. Cancel the x, and we wind up with 47 over 12x. So it will work, but it requires simplification. It would be better instead to go for the least common denominator by multiplying this by 3 over 3 and by 4 over 4, giving us 20 over 12x plus 27 over 12x, resulting in 47 over 12x. And now we don't have to simplify. But it's a little bit different with binomials. Try the following. Simplify this subtraction. Pause the video and we will talk about it. Okay, so in this case, we don't need to do anything to the fractions because they already have common denominators. So we can turn this into 5x minus 5y over x minus y. Simple enough. Are we done? No, because as we've already learned, we can simplify rational expressions, single rationals, by factoring numerators and denominators and canceling common factors. So there's a greatest common factor in the top of 5, and when we factor that out, we wind up with a common factor of x minus y on top and on bottom, and those two cancel, leaving us with 5 over 0. No, not 5 over 0. 5 over 1. When you cancel a factor completely, a 1 is left behind, which is then simply 5. So this is adding and subtracting where there are binomial denominators. But it's going to get a little bit more complicated when we look at this. Pause the video and try this out. This takes a little bit more thought. It is important to note here that when you make common denominators, you are not allowed to add numbers to the top and the bottom to turn this into 4/9 plus 11/9. That doesn't work because we didn't multiply by 1. We added to the top and the bottom, and 5/3 is not the same as 11/9. This would be a mistake. A lot of students mistakenly see the expression above and think, well, I can subtract 6 from on top and on bottom in a similar fashion, giving me x plus 3 over x minus 7 plus x minus 8 over x minus 7. This does not work. When you're getting common denominators, you can't subtract from the top and the bottom. You have to multiply the numerator and the denominator. Furthermore, some students think that to get the 7, all we have to do is multiply by 7 over 7, and that this will give us common denominators. But as I'm about to show you, this won't work either. This would give us 7 times x minus 2 is 7x minus 14. 7 times x minus 1 is 7x minus 7, because you distribute to both. Did we get common denominators? No, we didn't. So this also doesn't work. So those are two common misconceptions of beginning Algebra 1 students. In order to get common denominators when there are two binomials, often you have to actually multiply by the other binomial. By doing this, we wind up with, and I'm going to multiply my numerators, x squared plus 2x minus 3. And I'm going to leave my denominator factored. Often, and you'll see this in Algebra 2, it's better to have denominators factored. Plus, I'm going to multiply my numerator by foiling, right? X squared minus 9x plus 14. Over, I'm going to leave my denominator factored. The book, I think, multiplies the denominators out, which is okay to do also. And now we have common denominators. So now we can add. This turns into one fraction, x minus 1 times x minus 7. And when we add these, x squared plus x squared will give us 2x squared. 2x minus 9x will give us minus 7x. Negative 3 plus 14 will give us plus 11. How do we know that we're done? We must take a look here and see, can this be simplified? And in this case, the numerator can't be factored, and there are no common factors, so it can't be simplified, and we are finished. It's a little bit trickier when it's subtraction. Try this out, pause the video, and we will talk about it. Okay, so we're going to multiply by 1 and multiply by 1, right? Those are both 1, so it doesn't change anything. And you'll wind up with x squared plus 9x plus 20 over x plus 4 times x plus 6 minus x squared plus 4x minus 12 over x plus 4, x minus 6. Now this then becomes one fraction over x plus 4 times x plus 6. But the subtraction causes extra complications. If we look at the numerator, this would give us x squared plus 9x plus 20 minus, and we're subtracting this entire numerator, which means that entire numerator needs to be in a parentheses, and that's going to make life a little bit more challenging. Make sure to realize that we are subtracting the entire numerator. So you're going to want to put a parentheses around that, or at least think about the concept of a parentheses being around that as a quantity being subtracted. Now we subtract. The x squared minus x squared will cancel. 9x minus 4x will give us 5x. 20 minus a negative 12 will give us a positive 32. So you got to distribute. Luckily, you've been doing that since 6th grade, so you should be okay there. Are we done? How do we know that we're done? Well, can we simplify this expression that we have at the bottom here? We can't, because the numerator can't be factored and there are no common factors as is, so we are finished. Okay, so let's try it one more time with the following. Simplify this, pause the video, and we'll talk about it. Okay, so there is no denominator under the x, but there is. That means it's over 1. So I'm going to multiply by x plus 3 over x plus 3. That's going to leave me with x squared plus 5x plus 6. And I'm going to skip a step. I'm just going to put it over x plus 3 right now, because I know they're going to have common denominators. And we're going to subtract from that parentheses x squared plus 3x. When we simplify this, the x squareds cancel. They won't always cancel, but they have in these two cases. 5x minus 3x is a 2x, and there's a 6 left. Are we done? No, in this case we're not done, because the numerator can be simplified by taking out a greatest common factor of 2. And by doing so, we now have a common factor of x plus 3. And the x plus 3's cancel, leaving us with 2 over 1, which simplifies to 2. All right, so that is adding and subtracting rationals, which was our learning objective for today. If you have time, we're gonna do adding and subtracting during class tomorrow. But if you have time, you might want to do some work with multiplying and dividing rationals. That's on page 467, questions 21 through 45. This video was a little bit long, but if you have some time left, you might want to take a look at some of these questions just to remind yourself how to multiply and divide rationals as well. And see you tomorrow.